The subject of this month's IoT Leaders podcast is what else? AI. Everyone's talking about it. And that's part of the problem. Everybody is talking about it. And a lot of people are getting very excited. And a lot of people are getting very confused. And people don't really know where to start. And so we decided that we would have an AI specific podcast. And we have gone to Australia for this. There's a great company called Minnovation. And we're about to, I'm about to talk to their CEO, Simon Maselli, CEO and founder, and they've done a lot of great work with real case studies on AI. Not only that, but they've got a very simple model for looking at all of the different components of AI at different levels and looking at what is the architectural taxonomy and what benefits does AI have at what layer of the architectural model, which is something that for us at SI we believe very strongly in. So there's a lot of synergy here. Simon's a great guy. He's in the office late at night in Melbourne, talking to me on the podcast, and I think you're really going to enjoy this podcast on AI in the IoT space, together with some war stories from my trip to CES last week. So with that, let's get going with Simon Maselli, the CEO of Minnovation. Enjoy. Hi, Simon. Welcome to the IoT Leaders podcast.
Nick, great to be here. Great to be here.
And I believe you're in Melbourne. That's right. So we're on the other side of the world to each other right now.
That's it. Communicating through the power of the internet. What would we do without the internet?
Well, maybe what we do is that we'll enhance it with AI, which is going to be the subject of today's podcast. So, but we are physical. We're not virtual. We're real. We're not avatars. But we are going to talk about AI. And before we do that, maybe just an opportunity for you to introduce yourself to the people who listen and watch the podcast, because you are the CEO and founder of a company called Minnovation. And so, look at your website. It says you're a digital transformation consulting and delivery company. So, why don't you give me a quick intro to what you do and maybe a couple of examples? We'll talk about case studies later on, but a couple of examples of the type of work that you do with clients.
Yeah, sure. So we essentially provide data and analytics as a service to most local government organisations here in Victoria, in Australia, but also to a lot of private organisations. So this is a lot of people who own lots of physical assets in terms of buildings and infrastructure and roads and all of those sorts of things. So the type of work that we typically do is we connect a lot of their operational technology systems, so their OT technology systems, merge all of their data from multiple sites, and the multiple sites might have different data sets in different formats. So we turn that into a really neat and aggregated data set that their analytics teams can take away and analyze. And if they don't have those teams, we also provide those services that do the analytics, and we even provide a virtual building management service. So we actually make recommendations and organise the contractors and all of those sorts of things on behalf of the end user and the customer, and driving a lot of those systems and a lot of those services is essentially AI, which is what we're talking about today.
And can you give me a couple of just high-level examples of the types of projects? Because I believe you work across Southeast Asia, not just Australia. So I know you're doing involved in a big building construction project in Thailand, I believe.
Yeah, exactly. So we were very fortunate to win the One Bangkok project. So that's probably one of the largest building construction projects in the world at the moment. There is over 1 million square meters of floor space, 32 towers, and what we're doing is we're connecting all of the building comfort data, all of the people occupancy data, a whole heap of different data sets from everything from underground parking to the building management systems, and providing that to the downstream applications. So they've got other applications that manage things like the tenancies, manage things like their air conditioning and HVAC systems. So we aggregate that data, pass it through to them, and that's been a really exciting project and a really large scale project for us. But we also work at the other end of the scale. So some people, particularly local government, have lots of these smaller buildings scattered around the place. And what's really important for them is to be able to manage all of those buildings, all of those assets in a central location. And again, those ones are the really curly ones, but they're the interesting ones because they have this unique need about having disparate data sets and having this data and this equipment that has a lot of legacy equipment in there that doesn't have modern connectivity with it. You might have on the other end of the spectrum a really modern, a really good system, and it's being able to bring all of that data together to give the end user a really great experience when they're analyzing and working with their data.
And so I believe just from a technology point of view, a lot of our listeners are on the tech side of it. I think I'm right in saying that you're collecting the data from, hundreds of thousands of sensors, but you're collecting it with LoRa, if I've got that right. And then if there's any backhaul or there's edge processing, and then using cellular to backhaul over the telecom networks, have I got that right?
Yeah, you're correct. So we've got two primary methods of collecting data. So a lot of the buildings that we enter into now, there's no infrastructure in place, or the infrastructure is very old, and it's legacy equipment. So in those cases, what we do is we put an in-building LoRaWAN system in place. That aggregates all of the data, and then we transmit that data back over a cellular backhaul, usually, to keep this separate from the client's IT networks. And there's various reasons for that. And then in the other instance, there are buildings that are more modern and have great connectivity, and they've got protocols like BACnet and RS485 or Modbus in place. So in those cases, we put an edge device in the system that works or connects to to the existing infrastructure, and also we send that back via cellular. So cellular in our world is very, very important for lots of reasons.
All right, let's thanks for that background. Let's move now to the subject of the podcast, which is AI. And I must admit, I listen to a lot of podcasts. I'm sure you do, listeners do. And it's kind of unusual now to listen to a podcast which doesn't have AI in it. This is the first time on the IoT Leaders that we've introduced AI. And one of the reasons is that we felt that there really hasn't been a clear view in IoT of what role AI will play. In fact, we just released our 2025 predictions report on our website, and we make three predictions, but one of them is 2025 is the year of AI for IoT. And we go into a sort of a three-layer model on that. And I think we're going to get into that in terms of the work that you do. But before we do that, I think one of the feedback that we get from people is, it's like the early days of the internet or the early days of networking. You hear all these terms, you hear all these acronyms. People, not everybody is following along with exactly what is exactly happening. And in the case of AI, it is moving so quickly. One of the stats that I remember is that the rate of change of AI is between 5 and 8 times per year. So we thought Moore's law was incredible compound growth. But when something is getting better at 5 to 8 times per year, you just do the maths and you suddenly realize, oh my God, the implications of this are enormous, and everyone is piling in billions of dollars. So from a landscape point of view, how would you describe what are the different types of AI that you see out there? Because a lot of terms are thrown around. It's not just one thing, is it?
No, it's not. And you listen to Sam Altman and some of these guys. He says that we're going to have AGI this year. General intelligence
General
this year.
intelligence.
It's
Yeah.
mind-boggling, right? But look, if I think if we take a few steps backwards, before we go to the top end of the AI, what will we call it, stack. You know, AI has been around for a long time. And in the 60s, there was these theories around what AI will look like, in the future. And there was two schools of thought that were kind of the most common back then, and one was this terminology called decision trees,
Yeah.
which were basically a series of logic that if this then this sort of thing, and that model was one of the prevailing models, and the other was this neural network model. And neural networks, the reason that this one's important is because that's pretty much what every modern AI has been built on. But the neural network is essentially a whole heap of different layers, where each layer process a little bit of information, and it's called a neural network because it kind of works similar to your brain and the neurons in your brain. And sitting on top of the way that this AI works and makes its decisions and makes its outcomes is all of these different families. And we've got these families like machine learning. Yeah. So again, machine learning is something that's been around for a long, long time. And if I remember, I'll come to a little story about it. But machine learning, again, something that's come out of the 60s, and essentially it's just math, and all AI is just math. Yeah, it's just the way that we process things and come up with numbers at the end of it. So machine learning is about processing these. It's really great for time series data and the way that it can process these sets of data and come out with outcomes. And it's good at doing things like finding anomalies and those sorts of things in data. Making predictions and what the trend is looking like, and finding trends and that sort of thing. We have another family that's pretty common in today's AI world, which is machine vision. And machine vision is essentially finding different features in a video or an image. So what it's doing is it's looking for patterns essentially in the image. It's looking for things like color and contrast and some of those more basic things that sit lower in the neural network. But then when it gets to the top, it's looking for features like shapes and sizes and those sorts of things. And that's how that AI finds images and objects in videos, and you would have seen on the internet. There's literally thousands of clips of the little car running across the screen with a little bounding box around it and that sort of thing. And
And
that's
little colored box around it. Yeah. Yeah.
yeah, and it looks really impressive, right? But when it comes down to it, again, it's all numbers. It's just finding these features, finding these patterns in the data, and that's what it's coming up with. And then probably the other common one is natural language processing. So that's kind of what ChatGPT is built on, and what this one is doing is finding patterns in language. Yeah, and you go into ChatGPT and you type something. What's my what's the most common, thing at CES, and it's going to give you back an answer. It's going to have televisions and, great audio, thing,
Well, I can
whatever.
having just come back, I can tell you what it is. It's sore feet. Um, from traipsing up and down the strip. But yeah, I went into the hall just as an aside. We're recording this the week after CES, and I went into the hall. Well, there were several halls, 140,000 people. It's a small, intimate affair, and it was hard to find anybody who didn't have the letters AI on their stand. I mean, suddenly everything was AI. And of course, it's, like there was cloud washing, there's now a lot of AI washing, which is why this is important to lay it out.
Mhm.
Suddenly everything is AI. And we have to separate let's say the truth from the marketing or whatever.
I, I tell you what, I was there last year. I missed out on this year, but I was there last year, and I went through the Samsung stand, and every single Samsung product was re-released, the same product as the year before, but it had AI stamped on
AI
it.
sticker on it.
And when I was walking through there, I was really frustrated. That's the word I'll use on this podcast. That what's this marketing hype, to pick up on your words. This is all BS. But I come away from that show and I thought about it, and I thought, well, actually, they are using AI in all of these products, because all of these products have machine learning in them. Yeah, they're processing data using these algorithms, which until recently weren't really referred to as AI. But now that this marketing spin's there and this marketing buzz is there, why not latch onto it? So I agree with you. I think it's overhyped in that respect. But I don't think that they're actually out there um, blatantly twisting the truth. I
Not
think they're
just the
telling the truth.
marketing.
It's the
And,
spin. Yeah,
and if you
yeah.
look at, I've been in the IT industry over 40 years, and Gartner classic hype cycle is that we are in the early stages of the hype cycle. But to your point, it is real. And one of the reasons it's real is that it is moving so quickly. I mean, even yesterday, just I don't know whether you saw it, you're in Australia, I'm in the UK. Our Prime Minister.
We're in front of you, mate. We're plus 11 at the moment, plus 11 in time. So
Okay, you're always ahead of us. There you go. That's what my Australian friends always tell me. You're always ahead. No, but our Prime Minister, who was under a lot of pressure, he's only about 8 months into his tenure, but his grasp of the AI flag and said, well, yeah, the economy's not good, the pound's not doing well, the yields on the bonds are all awful, but don't worry, we're going to put AI across everything, and the NHS is going to be transformed now with AI, and there were lots of things on the TV today. So it's not just the tech companies that are sticking the AI label um, on it, and you've laid out the landscape there, and so what it shows, it kind of reinforces what I was saying earlier, is that if you're I was going to say a layman, but if you are just somebody who is like I am as a CEO of a company, and I'm thinking. I'm looking at AI in terms of what can it do to our offering. We have about 800 IoT customers worldwide, and we have we do a lot of processing of data, and we do make manual choices by looking at data. So can we automate some of that? But also just in terms of the admin, are there things that we do that we don't have to do? And the way that you're describing it though is that there's a lot of different pieces and there's a lot of different layers, and there's no one AI yet. We don't have artificial general intelligence. We AGI, although apparently it's coming very, very quickly, where the systems are more intelligent than the most intelligent human. Um, uh, but but there's all these different tools, and there's going to be more tools. There's going to be more fragmentation. We know that because that's what happens with with technology. So, is there a taxonomy that you can lay out, which is that where AI, instead of the tools, because the tools will always change, is there some in terms of a network topology? It seems like AI is going to be used at different points. I mean, we talked about edge processing, we've got the cloud. Do you see AI being used in specific points in the network, and that will then lead people into choosing the right tool for the right job?
yeah, so I was talking a little bit about a solution that we're very good at. That's video analytics. So the way that a typical video analytics solution works for us is we've got the edge processing component. So at the edge, we've got an NVIDIA enabled device, GPU enabled device that does things like detects the objects in the video stream. It does things like plots the path of where that particular object is going. It identifies counts across a line, all of the basic stuff that you expect a video analytics solution to be able to do for you. Yeah. And actually there's cameras out there now. The Bosch cameras are a great example that actually do that on a camera on a really lightweight chip. Yeah. So these models are really lightweight. They're great for deploying, out into the field. And they send their data
AI in the device. That's AI at the edge.
at the
It's
edge
you
on the
can
device.
deploy,
Yeah.
you're not taking the data back. So it's really the intelligent edge that we've been talking about. Great
Intelligent edge. That's
video.
that's
Great
that's a
for
great,
video
great
where
summary. Yeah.
possible. A video is a great example, isn't it? Because there's so much data to analyze. It's so complicated, the patterns, the anomaly detection, and now you're seeing consumer products, household products that have AI embedded in them. It's a good
Yeah,
example.
Nick, and then the second part of this though, and the bit that I was trying to get to is we then take things like those paths and put them into a more powerful model in the cloud. So we take a path of a person, for example, we take the path of a vehicle. We look at the angle that they're going to intersect at. We look at the velocities of both of those paths, and we predict the likelihood and the consequence of that um, uh, impact, potential impact. And we give the end user a really great likelihood and consequence of all of these near misses taking place on their road or on their forklift in their warehouses and those sorts of things. So that's stage two of the AI. And then what we do in stage three is we take that data, we take the edge data, which is the counts and those sorts of things. We take the more complex data, which is some of these things like near misses and gender identification, or maybe it's face identification where we can identify employees or these sorts of things, and we give it some context and meaning, and we use a large language model to then turn that complete scenario into a story for the end user. So what happens is we've gone from a simple video feed, which is, what it is when you're looking at it, and turning that into data that can be turned into a story that says, in the last month, and I'll give you a typical example. We give one particular customer a report that says in the last month you had 14 incidents with forklifts. 3 of them were near misses. They were A category, which means there's potential, hospitalization or death injury. Here's what it looks like, and there's a whole heap of people within that organization that love this data. The health and safety reps love it. The CEO loves this data. Even the workers on the shop floor love this data because it's really, really simple. It's really, really digest. They don't have to think about analyzing the data or looking through graphs or looking up their KPI chart for the month. It just lands in their inbox. It's got a little story around it that's a paragraph long. If they want, they can click the report, and it expands the story using language processing or using a GPT engine. And we've done something that historically would have taken somebody a week or weeks to produce every month in the matter of seconds.
And yeah, that is a good example because not only would it have taken them weeks or months, given the number of things has now exploded, the number of devices, the number of cameras in your example has now exploded. There's no way you could even attempt to apply that. You could analyze a few cameras for a few incidents, but if you've got 5,000, 10,000 cameras, you're one Bangkok, or God knows how many there's going to be in 38 buildings, I think you said, that you couldn't even attempt it, therefore you didn't do it. As an example of a business, a process and a productivity improvement that is enabled by IoT, and it still leaves the human. You talked about what you do as a company doing buildings and Bangkok. I believe you've also got a pretty big, is it a water monitoring project that you do as well?
Yeah, so we do a number of water monitoring solutions, but I think the one you're referring to is the water pollution
That's what I
solution
meant.
that
It's
we've
the
implemented.
pollution
Yeah,
one. Yeah,
yeah, so that's a really interesting one as well because the challenge we had with this one is that a typical solution would look like you would install some water monitoring devices. You would set a limit, and if things went outside of that limit, you would flag an alert, and somebody would go down and have a look. But we had a particular organization that wanted to achieve that sort of scenario, but their data was a lot more complex in that they were measuring underground waterways. So these were sort of water pollution tunnels. Or wastewater tunnels,
yeah.
and the challenge was in different temperatures and different flows through that tunnel, the VOC levels changed a lot. So the pollution levels were changing. So what we had to do for this particular customer is a multimodal analysis. So we had to look at not only so what would happen is that even a normal flow or a normal pollution level could potentially trigger that alarm in high flow. So during a rainfall event, or there might be other factors that were triggering these alarms. And the end user had to report this data to the EPA. So they're reporting all of these false alarms, and the EPA was saying, "Hey, this is a real problem. We need to do something about it." So the solution was to do a multimodal analysis of that data. So we did a multimodal uh, anomaly detection. So what we're looking at is flows through the drain. We're looking at those VOC levels, and we're also looking at temperatures. So what that did is that meant that our alarm point was able to move up and down along with all of those parameters, so those three parameters together. And we reduced the false alarms by a long way. In fact, we reduced it so much that they weren't getting any alarms, and then they were concerned. And all of a sudden, they had an alarm, so they said, "Oh, we're going to go down and investigate this alarm because we haven't had one for a while." And what do you think they found? They found a major pollution event. They were able to report it to the EPA, and they were able to, get somebody. I don't want to say in trouble because of our technology, but go through the right process to make sure that this pollution event didn't happen again. Um, Again, this was a multi-staged process as well. So we did this processing at the edge. We passed the data into the cloud. We did a secondary analysis, and we've got a patent on the way we do that, but we've done a secondary analysis looking at a bit more detail of the data, and then we turn this into a story using the LLM or the GPT to give the end user, this one paragraph email that says, "Hey, you've got a pollution event here. You better go and check it out straight away." And these are the factors that we've picked up. Again, all driven by AI.
It, it's interesting your taxonomy, because we didn't know each other prior to this podcast, but I talked about our predictions report that we just released, which it's our number one piece of downloaded collateral every year, and there's three, and one of them is on predictions, one is on AI, as I said, but it's exactly the same model. It's the edge. There's the application layer. And for us, the slightly different one is the network layer in terms of specific IoT. So for us, the edge is the intelligence in the edge for the edge to make its own switching decisions, because a lot of these devices are multi-RAT. Just talking about our business a little bit. So you might have LoRa, you might have Wi-Fi, you might have increasingly satellite, you might have cellular, you might have multiple cellular signals. So there's a really complicated switching logic needed to be applied to which is the best connectivity for this device right now. So that's edge. The video, the one that you say is exactly the same layer as us, is the application layer. And we see a big explosion in video at the edge. So the amount of data, as we look, I talked in a previous podcast, the cost of data in cellular has come down about 9x, 10x in 6 years. But actually, the ARPUs, the average revenue per unit, has stayed flat. And what that shows is the amount of data that's being transmitted. Think of vending machines now is basically a big video, screen, interactive video screen, and then a bit of telemetry. So it's completely flipped. But the processing of the anomaly detection and everything is also done, needs that application level artificial intelligence, because you're looking at how someone is interacting with a vending machine or camera security, etc. So that's exactly the same. For us, the third layer is slightly different. Is that it's the network layer. So just in IoT, when the SIM becomes an eSIM, and it can connect to any operator once you've broken that 40-year lock on the SIM, you then want to be able to say, the device needs to pick an operator, but it also needs help in that, can it sense the signal strengths or the latency of networks, and then you have lightweight M2M doing the artificial intelligence analysis. So you have long tail personalization of every device makes the right connectivity decision based on not just the data that it's seeing, but the network, and from the sensors, but the network state. So it sort of sniffs the network. And we did a separate podcast on why for 5G implementation across multiple operators, you would have to have this three-layer model because everyone is implementing 5G in a different way. So AI is kind of like the enabler of 5G to the edge, but it's the same taxonomy model that you're talking about, and it makes a lot of sense on these AIs. So let's, if we can, the time we've got left, just go into what's changed and sort of conclusions. I think if we look back, we talked about people have been analyzing data. I think you started off by saying since the 60s. It's not new. And I remember about 10 years ago, it was all about, if we'd been doing a podcast 10 years ago, it was all about how what you actually need to do is, I remember going to conferences, Gartner conferences, you need to hire data scientists. If your kids are going to university, get them to do data science because that's where they're going to earn a lot of money. We're going to need loads and loads of data scientists, and they're now the new, powerful people in the IT department. This changes that model, doesn't it?
I think it does. I think it definitely does. Um, I think the role of the data science scientist is definitely going to change in the years to come. So today, a data scientist, we think about a data scientist. They're analyzing data. They're wrangling different sets of data, putting it all together, trying to make sense of it, trying to find the insights. Trying to do some of those pieces of work, trying to find the anomalies, trying to find the patterns. And when I talk about that word anomalies and patterns, I've used that a few times during our conversation because that's what AI is really good at and can do it a lot faster than what a human can with a lot less mistakes. So I feel as though, particularly as AI matures, the role of the data scientist, as we see it today, is definitely going to change. Now, do I think that data scientists will become obsolete and not a good career choice? I think I'm saying no, the opposite. I think I'm saying that their role will change and they will actually sit above the AI and they will be the ones that will be training these models and they will be the ones that will be having to reinforce what the AI is telling us and they will be
Interp-
doing some
Interpreting it.
interpreting it. Yeah, exactly. Right, and let the AI do the grunt work. Yeah, let the AI do the heavy lifting, if that makes sense, of the data, the data analysis process, and let the data scientists, focus a little bit more on the outcomes. I think AI is going to become something a little bit like IoT was a few years ago. Yeah, so if we think about IoT, I remember when I first started this company there were people coming to me saying, "Oh, I've heard about this thing IoT. We need to do IoT in our business." And
Mm.
you sort of think about IoT then was okay. We need to find something. Here is this technology. Let's try and find something we can solve with it, or try and find
Yeah.
a solution. Yeah, and AI I feel is at that space now. Yeah, we've got this great capability, but the use cases haven't really become as common as what the solution is, if that makes sense, or as commoditized what the solution is. But I feel as though once people start to figure out that here are the use cases that AI works really well for, that's when we're going to see an explosion in productivity. And if you hear, the way Microsoft talks about AI at the moment, they're talking about these agents. Yeah,
Yeah.
so AI will not become this great big Skynet. AI will become all these agents that are doing their piece of work really, really well and enhancing what the human can do. Do all of that grunt work, give it to the human to then make that decision for the things that are important, and maybe it's community benefit, maybe it's some other sorts of solutions that AI isn't really good at. I hope
And
that
you could
makes
argue,
yeah.
and you could argue that that's exactly, if you go back to all technology. I mean, from I was at CES and looking at Caterpillar, the big digger company. They don't describe themselves as that, but they had this massive, great big open cast mine product. I don't know how the hell they got it into the hall. This thing was absolutely enormous. You needed a ladder to get into the cab. But actually, when steam shovels were invented, then the work just changed, and people, instead of doing the grunt work, did different types of work in construction. So the work moved upwards. All spreadsheets took the grunt work and the basic analysis out, and then people started analyzing the data. And what you've just described, with AI, now we're seeing incredible models. The difference is the amount of data that can be analyzed. You got the that protein folding example where you can now predict protein structures in minutes that would
Mm.
have taken years. So we're not talking about 1x, 2x, 3x better. We're talking 1,000, 10,000 times better. And I think that's one of the big differences, is that now you can really start looking at examples like your video example, where you couldn't even think. It's not just that you're going to take an existing process and make it more efficient. There are things that you can now take on that were unthinkable, which will create new opportunities, new growth, new competitiveness, new revenue streams for companies.
Yeah, absolutely, absolutely. And look, I think the driver of this has been a convergence of technologies. Yeah. So it's only been the last few years that some of the hardware that we've got available to us has become mainstream. Yeah. So the NVIDIA processing units, the Jetson units that drives pretty much every video analytics solution across the planet, um, has come that far down in cost that it's a commodity. People can go out and buy one of these GPU processors for less than they pay for a Mac computer. So this technology cost coming down and the computational power that's available to us, as well as these new methods in terms of the software that's driving all of these things. As well as all of these other enabling technologies like the speed of cellular now and the speed of networks and these large data centers and these sorts of things. This is what's enabling. So look, I was this talking next about wave of innovation I was talking that's about taking over. the price of computation has come right down. There's all of this different software now that is able to be leveraged. Not just developing something new, but we're able to build upon that. The stack. There are networks and those sorts of things that are a
Hardware
lot more
components, the
faster and those sorts of things.
servers,
Yeah.
everything come down in price.
And I was sort of saying that industry 4.0. So we've had industry 1, 2, 3. Now we're at the edge of industry 4.0. So we've had this industrial revolution 3, where everything become automated, and machines become automated. They're able to do their own thing through robotics. And now industry 4.0, the promise of industry 4.0 is that these systems become interconnected. Yeah, so they're not just operating on their own, doing their own thing. They're looking at the entire process, and giving you another level of efficiency again. And a company that we they're actually an investor in us. They've moved all of their operations out of their Australian mines. So what they've done is they've put together a Malaysian command and control center. So all of their Australian command and control centers, their SCADA systems, feed back to Malaysia, and that's where they've got their operational personnel sitting there and monitoring all of their operations across Australia and across the world, by the way. So this is Industry 4.0 at its early stages. But if you then bring AI into that fold, and you take those operators away from having to sit there and watch a screen and get AI to start making a lot of those decisions, all of a sudden, we're starting to live in a very different world to what we live in today. And you apply that to any other industry, whether it's driverless cars, all talking back to some sort of central command and control center, so they're all coordinated. The buildings that we do at One Bangkok, yeah, or across the local governments, all of those buildings doing all of their things and making their own decisions, on their own, but being interconnected and having complete awareness of one another and the impact of their decisions against another. It really changes the world in which we live in, I guess.
It does change, and actually it has changed. And just a final comment on my trip to CES, I went in one of the halls, which is the one that has the big pieces of equipment. I took a big Caterpillar digger in there. But the other thing they had on the Caterpillar stand was a little virtual reality headset and joystick and chair, and actually what that was exactly what you just said. It was the ability to control devices, Caterpillar products that were hundreds of miles away from an office environment. It's a remote control system capturing all of the data across your fleet of construction equipment, being controlled virtually by one person sitting in front of a computer screen. And they were demoing that at CES,
Yeah.
and then all the data and all the analytics and all of the video, and you're getting real-time video back from the device. So absolutely, the companies that are making the products are absolutely moving. I think Industry 4.0, which has long been touted many years, but not really realized, I think perhaps what AI could unlock it. Just to finish, I guess in a sense, it's a rhetorical question. I think you're going to say absolutely, but I do believe that what you've been talking about really does underline this. Advice would be to people, um, you need a partner to do this, right? I mean, you need it. The landscape's changing. There's so many different opportunities. There's so many different tools. There's so many areas where it's not applicable. You need to look at the three-layered taxonomy, the architecture that we talked about. I guess your overall, your conclusion would be, and it's the business that you're in, is that you need a partner to help you navigate through this landscape because it's changing so rapidly.
Yeah, let me give you a bit of a long-winded answer. I'm not sure how much time we've got, but you think about the AI maturity curve or even the IoT maturity curve, yeah? Every organization needs to step through that curve before they can realize the benefits. And the curve, for those who don't know, sort of starts at the bottom with some very basic early steps into whatever we're talking about with low return on investment. And then when we get to the top end, it's more advanced solutions, but there are higher returns on investment and those promises. We're just talking about Industry 4.0. And any organization in the past, let's say IoT, would have been able to go through that journey on their own, make those mistakes, make those successes, get the organization to change and adopt those new technologies, and walk the way through the landscape, and eventually get to the higher stages of maturity, so they get those promised returns on investment. I think the challenge that we have with AI and all emerging technologies today is that the goalposts move so quickly. So is that these higher level returns um, are changing so rapidly that the speed that it takes an organization to learn and go through that maturity is slower than what
Yeah.
they can get to the front at.
They're
So what you
chasing
need
the
to
ball
do.
that's bouncing down the stairs and they can never catch it.
Exactly. So the only way, or the most efficient way, rather than spending lots of money and putting lots of resource into it, is to partner with somebody that's been there, walked the journey, has knows what the end goal looks like, so they can accelerate your progress through that maturity curve as quickly as possible and get you to that return on investment as quickly as possible. Because that's what it's all about for business, right? Whether you're in a local government that's spending ratepayers' money, or you're in a mining company, or whatever it turns out to be. Unfortunately, money makes the world go round, and we need to get that return on investment, to really really change things. So that's what the goal that we're all chasing is. I stumbled over my words a bit there, Nick, but I think you got
No,
the
but that's the business that you're running, and that's what you do, and your case studies are very, very relevant. And as I said, since the first one we've done on AI, it won't be the last. Maybe all of them going forward. We'll have our own AI sticker on all of our podcasts going forward. But we did want to get into the what's real, what's not, and the architecture and the use cases. I think you've done a great job, Simon. I really appreciate it. I know it's late for you. You stayed in the office late in Melbourne for us to allow me to record it during office hours here. So I really appreciate that. And thank you so much for being our guest on the IoT Leaders podcast. And if people do want to find out more about your company, it's Minnovation, isn't it? So it's like innovation with an M. Uh,
Funny,
And
funny you say that's how the name come about. So we're registered as a company called Metamorph. And when I used to say metamorph to people, I used to say, how do I spell that? And I'd spend 5 minutes trying to spell it out with people. So, I thought, I've got to change that. I've got to make that easier for people to find and spell and all those sorts of things. So I took the M out of metamorph and thought, oh, well, we do some innovation stuff. Let's make it innovation. Well, that actually created another headache or a whole another set of headaches because people were saying, is it M space innovation? Is it Minnovation? Is it M dash innovate? So I don't know if the grass is always greener on the other side of the
but
fence.
I know there's a few Minnovations out there because when I Googled it, I found three or four and I had to. So let's give the full URL. What is the full URL so they don't get the wrong Minnovation if they look you up? What,
Uh, M innovation, so it is Minnovation,
yeah.
but M in front of innovation.com.au. We're an Australian company. Although we work through Southeast Asia, we're based in Australia, so look for that AU on the end.
Excellent. All right, Simon, thanks very much for educating everyone. Congratulations on your use cases, and on the basis that it's changing 5 to 8 times faster every year. We might need to do another one in a year's time because all of this will be completely out of date.
Mate, I've enjoyed the conversation. It's great.
Great.
Great to hear about your experience at CES as well. I love the place. Yeah.
I'm glad it's once a year. All right. I'll talk to you soon. Take care. Thanks again.
Bye.